Hello everyone. So we will proceed further, and we will see the next question, and that is what is negative sequence relay, and basically why are we generally use this particular negative sequence relay. See, this negative sequence relay we use in in synchronous machines to protect our synchronous machines from the overheating. Okay, so why this? Why there is a requirement of negative sequence relay? How it cause overheating in synchronous machines and all? We will see. So let's say you have a synchronous machine with you. Okay, so let's say this is your stator part. Okay, and in stator you'll be having three phases, right? A phase, B phase, C phase. So this is your stator, let's say A prime, B prime, C prime, okay? And you have A phase, B phase, C phase, okay? Now, let's say you got a unbalanced load in the synchronous generator. The load that is connected to synchronous generator, it is a kind of unbalanced load. So the current IA, IB, IC are not balanced, okay? So this IA, IB, and IC, these are not balanced. So if these three currents are not balanced, then according to symmetrical component theorem, or you can basically split this particular unbalanced current this particular unbalanced current can be split into positive sequence component of current and negative sequence component of current and zero sequence. There is something we call Fortescue theorem. Okay, so if you have a unbalanced three-phase system, that can be split into two balanced system, like one will be your positive sequence, another will be negative sequence, another will be co-phasal or the zero sequence component of the current. Okay, now you might have studied, like if three-phase current uh, flows to a three balanced winding, then rotating magnetic field gets generated. Okay, now here I am interested in the negative sequence component because of the unbalance. So this is my IA, this is my IC, this is my IB. Okay, so this is my negative sequence. So A phase, C phase, and B phase. So AC, B phase, basically we call it as negative sequence components. And this, if this negative sequence component of current is flowing through the windings A phase, B phase, and C phase, that will produce a rotating magnetic field that will rotate in opposite direction with speed of omega s. Now, in case of synchronous machine, let's say your rotor was initially rotating at clockwise direction, and because your rotor is rotating its clockwise direction, the voltage that will get induced here also, the frequency of the induced voltage will be in clockwise, like frequency of the induced voltage will be omega s, and because of that positive sequence component of current, the rotating magnetic field that gets produced in the stator, you can say, that rotating magnetic field is rotating in the clockwise direction. So this is because of positive sequence, and this is because of negative sequence. So let me explain you one more time. So I have, because of this unbalanced current, I have positive sequence. This is my positive sequence, IA, IB, IC. Okay, and this particular positive sequence component and like will be decided by the rotor rotation, like in the direction of the rotor. The rotating magnetic field will also be the same direction of the rotor and direction of the rotating magnetic field created by the positive sequence of the current. This was same. Okay, so your rotor is rotating in clockwise direction, and also your rotating magnetic field, because of the positive sequence current, is also rotating in the clockwise directions, and because of the negative sequence current that is flowing in the stator windings, these are the balanced stator windings, so that negative sequence component will also produce a rotating magnetic field that will rotate in rotate at omega s speed, but in opposite directions. Now there is two rotating magnetic field, positive, you can say positive rotating magnetic field, and there is negative rotating magnetic field. But here my positive rotating magnetic field is dominant. Okay, and basically if you see, my rotor is also rotating in clockwise direction. Okay, so just think from the rotor point of view. the frequency of the voltage that will get induced in the rotor circuit, what will be the frequency of that voltage? S- Something is rotating in omega s speed, because rotor of the synchronous generator is rotate at synchronous speed only. So omega s speed is rotating in clockwise direction, and you can say the negative sequence rotating magnetic field is rotating in opposite direction. The relative motion in between the rotor, you can say rotor, and the negative sequence rotating magnetic field will be 2 omega s. So the frequency of the voltage that gets induced in the rotor circuit, it will be twice of the supply frequency. Okay, and this supply frequency, you can see it has increased by 2 times. And basically we don't use any kind of lamination in the rotor conductor, because rotor is designed to handle DC part. It is not designed to handle any AC component and all, because rotor has only DC excitation, so we don't generally have any sort of lamination and all. Okay, so because of this, twice of the supply frequency voltage gets induced in the rotor circuit, you the rotor irons, rotor materials, there will be huge core loss, because your eddy current loss and hysteresis loss, those are the depends on the you can say the frequency. And eddy currents and if you see the eddy current equations and all, P eddy current is equals to Ke F square Bm square T square, like that, right? So Pi, and hysteresis loss is Kh Bm to the power 1.6 roughly, and F. So you can see if there is increment in the frequency, your eddy current loss and the hysteresis loss that are associated in the rotor core will also increase. So there will be you can say much more core loss in the alternator or synchronous machines, and that can lead to overheating. So to reduce this phenomena, or to completely eliminate this particular phenomena, we use negative sequence relay. In negative sequence relay, the actuating quantity for negative sequence relay is basically the negative sequence component. So we'll be having some measurement in these lines, and if the negative sequence component is significantly high, or it is more than the specified value, then the negative sequence relay will send the trip signal, and my circuit breaker will simply trip the lines. Okay, and this is how it will basically operate. So bottom line is, by having negative sequence relay, you can protect your synchronous machine from the overheating. Okay, yeah, I hope it is clear, but still if you have any doubt, you can ask me in the chat. Thank you.